more on dummy variables. We often use dummy variables to shift the y-intercept. It doesn't change the other linear terms. So for example, considering a regression, wage is beta naught plus beta 1 age plus beta 3 times some dummy variable d plus the error term. For people who have that dummy variable value equal to 0, their wage is determined as beta naught plus beta 1 age. The other people, for whom d equals 1, are going to see parentheses beta naught plus beta 3, that's their intercept, plus beta 1 age. But what if we want to change the slope on age? What if people with that dummy variable equal to 1 accumulate experience differently, or accumulate the rewards to experience differently? Maybe we want a different slope. We might think that delta wage, delta age could be different between groups. Now, this model does not require it different, but it allows it to possibly be different. To accomplish this, we add some interaction terms. We interact the dummy variable d with the age variable. And by interact, I mean nothing more than the simple mathematical operation of multiplying the two together. We create age times d. Why? Well, if we break that down into two segments, we can see what's going on. For people with d equal to 0, the base group, they still have the same regression, beta naught plus beta 1 age plus some error. But the other group are going to have beta naught plus beta 3. They're going to start with that different y-intercept term. But then the coefficient on age will be beta 1 plus beta 4, in parentheses, together multiplied times age. People in group 0 have delta wage, delta age equal to beta 1. But for people in group 1 with d equal to 1, they're going to have delta wage, delta age equal to beta 1 plus beta 4. Now, it's not a requirement that they're different. The regression could estimate that beta 4 is about 0, meaning no perceptible difference. If you work through the math, you can rewrite the equations in a few different ways. Sometimes it's easiest to write out two separate equations. One for people with a dummy variable equal to 0, and the other for the people with a dummy variable equal to 1. Just whatever works, whatever helps more. But once we start with interactions, we can just keep going. What if we want delta wage, delta age to change both for different groups and different ages? More interactions. That's what we're going to have. There's that beta 2 that we skipped before. Now we model wage equal to beta naught plus beta 1 age plus beta 2 age squared plus beta 3d plus beta 4 age times d. That's the interaction of linear age plus beta 5 age squared times d. That's the interaction term with the age squared term. Again, the clearest view comes from rewriting these for the groups with different values of d. For people with d equal to 0, we have the same age profile as before. For people with d equal to 1, now each of these coefficients might differ from the default group. So in that graph, I've shown maybe possible profiles. There's a good deal of complexity in that picture between the red and the blue. Which one is better? It depends. Blue starts lower, but gets higher, then comes down more sharply. Red starts higher, doesn't grow as fast, but peaks later. And those might be tough to see if you just stare at the equations. I mean, I don't know how much you remember of your algebra class from long ago in like elementary school or whatever, but often it's helpful to draw the graph from the equations for the two groups. People with d equal to 0, people in the base group have a typical equation. Wages beta naught plus beta 1 age plus beta 2 age squared. For people in the other group, d equal to 1, the intercept term, beta naught plus beta 3. The coefficient on the linear term is beta 1 plus beta 4. And the coefficient on the squared term is beta 2 plus beta 5. Those additional terms might not be different from 0, and we have statistical tests to assess how important that difference might be. With a little bit of calculus, oh, joy, we can see that people in the base group have delta wage, delta age as beta 1 plus 2 times beta 2 age. You can solve for that where, find where it equals 0, find the maximum for that group of people. For the other group, people with d equal to 1, now delta wage, delta age is going to be parentheses beta 1 plus beta 4 plus 2 times another parenthesis beta 2 plus beta 5 multiplied by age. You can think of it as just taking those earlier two coefficients, beta 1 and beta 2, and modifying each of them. Now, it doesn't mandate that the two groups have different profiles. They could be the same if beta 3, beta 4, and beta 5 are all equal to 0. Hey, we've talked about how to test restrictions on multiple regression coefficients to assess how strong is that restriction. The two groups might have very similar wage-age profiles, or perhaps they could be different. We can let the data tell us. Now, we're not as interested in the individual coefficients. Could it be very weird to use, maybe beta 4, not different from 0, and conclude the model ought to restrict it to be exactly 0? That's not okay. You can't pick off just a few selected coefficients of the polynomial. Do a joint test, make it serious. Now, another way to look at these dummy variables is to imagine doing two regressions of the two groups. People with d equal to 1 do one regression. People with d equals 0 do a separate regression. That works. You get the same results and find these equations in the third line. However, if we use dummy variables, then the statistical test is going to be a little easier. Now, interpretations of dummy variables are really easy. Maybe the interactions are a little too easy sometimes. In R, you do a linear model of y is x plus d plus x colon d. That colon there is telling R to include all the interactions. Even a shorter notation is just x star d. It will estimate the separate individual coefficients plus all the interactions. That can be very efficient if you know what you're doing. Sometimes a little crazy making if you're left wondering where did all that output come from. In the data sets we're using, sometimes you tell R to treat certain variables as factors. That'll create the dummies that are needed, and you can interact them together to your heart's content. Other questions might arise. Can I interact dummy variables with each other? Yes, you can keep interacting and interacting and interacting. You can interact dummy variables for, say, occupation, with dummies for gender, with dummies for education. Maybe, for instance, a college-educated woman in the public sector who's a teacher is going to have a different wage-age profile. That's a plausible hypothesis. Might be tough to estimate it, but there's absolutely an issue with sample size. Dummy coefficient estimates are based on the means of subgroups. To estimate industry, occupation, gender, and education dummies, we've got to look at what is the average wage of each of these interactions. People in a particular industry, in a particular occupation, with a particular gender and particular educational qualification. What's their average wage compared with people in the next industry, or next occupation, or next gender, or next education? We're cutting into smaller and smaller subgroups, so larger error values. There may not be, say, too many people in the farm industry in New York with an advanced degree. Sure, there's some, but not necessarily enough to get a really precise estimate of what are their wage outcomes in general. I'll leave you with a bit of a teaser that multi-level models, which we'll cover later, can be very helpful here. Finally, a sidebar on how the government creates industry or occupation dummies. Usually these are multi-level codes where more digits drill further and further down, more detail. There are similar coding schemes, used for products and production, trade statistics. For example, industry dummies, the very first digit gives a very broad categorization. 0, farms and mines. 1, manufacturers of non-durables. 2, durables. 3, high-tech. 4, transportation, utilities. 5, wholesale. 6, retail. 7, fire, F-I-R-E, finance, insurance, real estate. 8, services. 9, government. If you have a 2-digit code, then the second digit is going to add more detail to the first level. 3-digit, 4-digit, 5-digit, 6-digit. Some of these go really deep. It can be complicated as you look over a longer time since the size of the industries might change dramatically, but it's all there for you to play around with.